Hello, students. Welcome to our channel 10 on 10. Today, we are going to study the part one or the introductory part of real numbers. Okay, in this chapter, we are not going to study real number chapter, but we are going to study the introduction of, or you can say the prerequisite, something that you already need to know to understand the chapter. Okay, we'll start studying the chapter from the next video onwards. So, first of all, let's see the content. So in this chapter, we have mainly two topics to cover. It is the properties of positive integers. What are they? Euclid's division algorithm and fundamental theorem of arithmetic. So let's go to the basics. But before that, we need to just have a slight idea of what kind of questions are asked from this chapter. First of all, you will have to understand the basic concept of LCM and HCF because there will be word problems on it. And then we need to know prime factorization and divisibility questions. And we have to find LCM and HCF using prime factorization, and also we going to study a rule and we have to verify, that is the fifth one, LCM into HCF equal to product of the two numbers. Okay, and then we have to prove if a number is prime number or composite number, and then we have the next type of question is proving rationality. All of these questions are very easy. It is a very easy chapter. We will learn and we'll also do so many questions. We have a revision, quick revision sessions after the main chapters. Okay, so let's go to the basic topics, the prerequisites that you already need to know before you start the chapter. First of all, we need an idea of what prime numbers and composite numbers are. So what are prime numbers? Prime numbers are the numbers that do not have any other factors except the number itself and 1. For example, 7 has factors 1 and 7. Yes, we know because 7 is a very famous prime number, and factors are 7 into 1. That is the only way we can get 7 through a multiplication. Similarly, for 13 also does not have any other factor other than 1 and the number itself, that is 13. Now let's see what composite numbers are. Composite numbers are the exact opposite, the numbers that is divisible by a number other than 1 and the number itself. So to know if a number is composite or not, we need to show that, we need to prove that the number is divisible by some numbers which is not 1 or the number itself. For example, 6 is a composite number because 6 has factors, not just 1 into 6 equal to 6, we know, but 2 into 3 is also 6. So we can say 2 and 3 are factors of 6, and 2 and 3 are not 1 nor 6. So we can say we have extra 2 factors. So we can say that 6 is a composite number. Similarly, 12 is also a composite number because it has 1, 2, 3, 4, 6, and 12. So if it had only 1 and 12, we can say it is a prime number, but it has so many other factors. So we can't say that. So next we are going to understand the basics of LCM and HCF. So first of all, let's see what LCM is. LCM is the lowest common multiple. What does that mean? It is a multiple, right? It is a multiple of few numbers, and also it should be common for the numbers. For example, if we are considering the LCM of 5, 4 and 10, so we have to, this LCM must be a multiple of 3, all the three numbers, and also it should be common. That is what it means by all the three numbers, right? And also we have to find the lowest possible common multiple. So in this case, we are just taking the multiplication table. Okay, multiplication table of 5. We know multiplication table of 5, we know it's 5, 10, 15, 20, and then we check the multiplication table of 4 and 10. You don't have to do this to find LCM, but I'm just introducing the idea. Okay, if you forgot what LCM was, just a quick recap. We will find we'll learn how to find LCM and HCF using prime factorization from the next video onwards. So here we can see 20 is the least common factor because 5 is the first multiple. 5 is not a multiple of 4, 5 is not a multiple of 10. But the second number, 10, 10 is not a multiple of 4, but 10 is a multiple of 10 itself, right? But we cannot say 10 is the LCM of these three numbers because 10 is not a multiple of 4. So the LCM of 5, 4, and 10 means 10 is should be a common multiple of all the three numbers. So we cannot say that. And then we find 20 is the LCM because 20 is present and also 20 is the lowest common multiple. Now let's just, yeah. So we are going to see a simple problem to understand the idea of LCM and why its application is very important. So a shopkeeper sells candles in packet of 5 and candle stands in packet of 3. What is the least number of candles and candle stands Laura should buy so that there will be one candle for each stand? So we need to we they don't they have said that there is 5 candles in a packet of candle and 3 stands in a packet of stands. So what do? We have to make sure we buy equal number of total candles and total stands. So how do we do that? If we buy, let's see the different possibilities. Okay, so in this slide, you can see the different possibilities. So you can either buy one can packet of candle and one can of packet of stand. What does that mean? It means if we have, there are two extra candles and there's just 3 stands for 5 candles. So that is not enough stands. So we need more stands, right? So we see the possibilities. If we buy 2 packets, how many candles do we get? 10 candles. 2 stands, we get 6 stands. And we have seen all the possibilities and we have found that 15 candles, that is the LCM, or you can say 15 is the LCM of 5 and 3, right? So you can say that if we buy 3 packet, when do we get 15 candles? When we buy 3 candles, I mean, sorry, 3 packet of candles. And then when do we get 15 stands? We get 15 stands when we have 5 packet of stands. So that is the lowest common multiple. In this case, that is the lowest number of candles that we can get um, while buying equal number of candles and stands. But there is other case. Just imagine if we buy 6 packet of candles, how many candles will be there in total? If we buy 6 candles, then there is going to be, tell me, 30, right? 30 candles. And also if we buy 10 packets of stands, we get 30 candle stands. So that is also equal. But that is not the lowest common multiple. That is just common multiple. So we find the lowest common multiple so that we don't have to buy 30 candles. Okay. Least amount, that is in the question, which is the least number of candles and stands Laura should buy. So that one candle for each stand. So let's see the next topic, that is HCF. Okay, highest common factor. Let's see what HCF is. This is just a very simple representation of HCF. We can find HCF using other methods also, but look at this one. First of all, we have the example 12 and 18. First of all, HCF is highest common factor. What are factors? Factors are the numbers that could be multiplied in order to get a number. For example, factors of 12 we have discussed before in the case of prime numbers and composite numbers. The factors, okay, we know that already. So we know that 12 has a factor 6 and 2 and 18 has factors 6 and 3. So while comparing, we can find that which is the highest common factor, which is a common factor, and also highest common factor is also 6. And then we find 56, 49, 7 is Y, 7 is the HCF. So similarly, this is a very simple way representation of HCF. This is not the exact thing. We will study to how to find HCF in a proper way using prime factorization in the next video. Okay, so this is just a basic. Let's see a word problem to understand the concept of HCF. So in this question, we have 2 wires. Okay, 2 wires, and both the wires are one is 12-meter long and the other one is 6-meter long. Okay, we are happy. And now we need to know what do we have to do with these wires. The wires are to be cut. Okay, we have to cut the wires into pieces of equal length. That means we have to divide each wire. And what is the condition? Find the maximum length of each piece. So we need to make sure we don't, you can either cut this 12-meter wire into 12 pieces, we get 1 meter each, and then you can divide this 16-meter wire into 16 pieces, then also we get 1 meter pieces each. So total we get so many pieces. I mean 28 pieces of 1 meter length. But that is not what we want. We need to find the maximum length of each piece possible. Okay, so let's see what are the different cases where we can divide. How can we divide 12-meter into different into different pieces? So in the first case, we have when we consider the multiplication of the factors of 12, considering the factors of what are the factors of 12, we have 1, 12, the number and 1, and then we have 2 because it's an even number. Then we have 4, 12 is divisible by 4, and also 3 and 6. So when we divide the, you can see in this representation in the table, you can see that the red color mark actually shows the length of the wire in the representation. Okay, so 12 in the first case, 12 into 1 means 12-meter length wire. How many wire is there? Just one, because that is a total amount, right? So next we have the next possibility, 12 into 1. So you can also convert it into 1 into 12. That means 1 meter length, and there are 12 pieces. So that is a case that is a smallest size that is possible. I'm not saying the smallest size possible, but comparing to the other cases, this is the smallest. You can divide 12 into 24, and then also you'll get 0.5 meter, but that is not something we are considering here. So because we need to find the maximum length of each piece, right? So let's go to the maximum cases. So first one, we have 12-meter, then we have 1 meter pieces, then we have divided the 12-meter wire into 2. That means 6 meter each, 2 pieces of 6 meter, and then we have 2 meter wire length of 6 in number, and then we have 3 numbers of 4 meter wire, and then we have 4 numbers of 3 meter wires. So these are the situation. And also similarly, we have the similar situations, but we don't have so many factors. And I think 12 has more number of factors than 16. 16 has, what are the factors of 16? 16, 1, 2, 4, 8. These are the factors of 16. So let's see what the answer is. Okay, so comparing all the cases, we can see that the highest common factor, because we need to find the HCF, right? To highest common factor, so that we can divide it into equal length. That means after dividing the 12-meter wire, the pieces should be equal. The length of the pieces should be equal to the wires that we get by dividing 16-meter wire. Okay, so in this case, when we divide 12-meter wire into 3 equal parts, we get each piece gets 4 meter, and when the 16-meter wire is divided into 4 parts, we get 4 meter each. So we can say that the HCF uh, gives the answer. To find the maximum length of each piece, we have to find the HCF. So you can just almost get an idea of what this HCF and LCM and prime number, composite number, we just learned this very fast, so that we just have to, because after starting the lesson you might not remember this. So I just wanted to give you a quick recap. So, and then from the next chapter on the next video onwards, we'll start the chapter and actual topics that are covered in the chapter. Good job, students! You have reached the end of the video. If you loved our classes, give it a like and let me know in the comments. Share it to your friends, and please, please, please subscribe to our channel. See you again in the next video. Goodbye.